Kilauea is just a short little volcano. It's the youngest volcano. It's the newest volcano on this island. And these volcanoes are all shield volcanoes. So that means that they have a topographic ridge that is what we call a rift zone. That's where magma moves under the ground through the volcano. There are currently 3 active flow paths down the poly, or the steep part of the Kilauea flow field. 2 in tubes. One is the original tube, which is now the western tube, and one is this newer eastern tube, and we're going to watch and see if that becomes the dominant flow path or not. And then there's that little flow that spilled outwards in the middle and burned through the trees. Now we also noticed, I commented at the end of the delta video that the lava was becoming sticky and it was harder for the lava to flow on the delta. We noticed that as well up here. We saw 3 breakouts. This was the first around Veterans Day, and we had 2 more farther and farther back up the tube that were erupting basically the same sticky material. And we weren't sure why that was initially, because we hadn't realized that the tube had become blocked. But this is what it looks like. We have the nice smooth pahoehoe here, and then this guy outlined in white is the breakout from the map on the last slide. These are people for scale, some visitors. It's about 50 meters or half a football field across. And it just looks really rough. It's kind of pokey, and it's just moving super slow, like slower than pahoehoe normally moves, which is still kind of slow. So we went back to our thermal maps that we make on our overflies, and we said, what the heck is going on? If lava's not coming out at the delta and entering the ocean, where is it going? And why is the stuff that's coming out down here so sticky? And we call this viscous. It means it's hard for it to flow forward. So this is the early September before the tube became blocked. We had a pretty fairly common breakout up here that would produce several flows over the summer, as well as around here. This had several repeated breakouts. On June 26th, there was one here that you can't see, but it sent this eastern flow down over on this side, which is producing all these active breakouts. And then the western tube occasionally has a breakout as well. That was kind of the status quo for the summer. But this is right around the time the tube got blocked, showing again the status quo. Maybe you could argue there's more stuff coming out of the western tube, maybe not. But after the tube becomes blocked, we see more breakouts in new places, and they're flowing to both sides of the flow field now. And that's just based on where the breakout happens on the tube and the topography around the tube. This eastern flow ends up forming its own tube. You can see that in this trace here. And sorry, I should have said the blue is colder lava from this episode, and the yellow is warm lava, and the red is active lava in these pictures. There's a thermal map as well, so it's showing heat of the rock. Yeah, so after the tube becomes blocked, we see more breakouts along the tube, and then these ones up here start producing more volume than they had previously in the summer. That's not necessarily because more volume's coming into the tube, it's because volume can't get out of the tube, so it has to come out somewhere else. And we see that this eastern flow has definitely made its own tube, and the western flow looks like it's cooling down. So we're going to keep an eye on this and just see what happens, but at the moment we seem to have 2 tubes in our flow coming down the poly. And then we had a breakout right in the middle of December that came down and burned through a kipuka, or a little haven of trees in the middle of the lava flow. And you can see that this upper breakout near the vent has really started letting a lot of lava out onto the upper flow field. So here's a video of this lava flow as it's burning through the trees. This is an O'o flow. So again, these are what we call clinker. These are little really pokey, rubbly bits that travel on top and line the bottom of the flow. And this is the hot inner core that's flowing on top of the clinker. So this video was taken by my colleague Matt Patrick and I, and we went out on December 21st to see this. This is the center of the lower part of the O'o flow. This is the channel feeding that flow front that you just watched. But you can see there's several areas where lava is flowing on top of the clinker here. And this came all the way down the poly, and it was impressive to me because it was my first O'o flow in person. So between the delta, the middle of the delta kind of slumping down, and the end of the year, we expanded the flow field over here from this eastern tube, and also filled in this little kipuka. And then we also had a lot of material come out, a lot relative to the fact that there's none coming out here, and resurface much of this upper flow field area. Now you'll notice that I didn't really talk much about Pu'u O'o cone for this past year, and that's because it's been pretty stable. So we'll finish up this talk, sorry, I went through that pretty fast. We'll finish up this talk kind of with a cliffhanger ending. So the story is still to be continued, and I will see you guys next year. But the things that happened at Pu'u O'o this year is that we had a little spatter cone up here, I believe from 2013, maybe early 2014, and that has fallen in to the lava stream that is feeding 61G. So that is now gone and just kind of a fuming hole in the ground. And then over here, Tim had set up a time-lapse camera before he left. This is the West Pit Lava Pond. It's much smaller than Halema'uma'u, which is the Summit Lava Lake, but it behaves in a very similar fashion. So this was the camera image when Tim first set it up on March 16th. And by the time I got there on September 21st, we realized, hey, wait a minute. Something's different about this picture. We've lost the skyline. The skyline's gone. So what does that mean? Well, we've also had a few rock falls, so these rocks are gone, but the camera is tipping forward. That's the only way to lose the skyline. So we thought, we should go fix that. So on the next trip out, we moved the camera. So the camera was here, and this is towards the north, off to this direction in the picture. So we moved it from northeast to slightly southeast. So that's down here. So this is the old camera site, and all of this kind of cracked area is what was slowly starting to tip into the crater. And we thought that this was going to be a great area because it was nice and flat and no cracks, and it was going to be awesome. But those of you who have really good eyesight, and if I had slightly better resolution on this image, you would see that the tripod is now there. And that's because we came back and this crack had widened, and our tripod was previously right there. And I thought, it's probably okay, but I don't really want to risk losing a camera, especially like my first month on the job. So we moved the tripod back, and that was a really hard decision actually, because it meant sacrificing a view of the lava pond. So we got 6 months of really great images of the lava pond. It convects very similar to Halema'uma'u, but a little slower. The crust is a little thicker, so it doesn't flex as much as Halema'uma'u, but when it's hit with a rockfall, it still behaves in a similar way, and it spatters. And it was a really good data set that we had for 6 months. But we moved the camera back in the hopes that we would see a bigger rockfall, and hopefully some ballistics come out of West Pit from the impact of this rockfall. And initially we didn't see much, and I thought, okay, maybe there's a little change in the ground. So this is the cliffhanger ending. This is where it stands today, and we'll see what happens in the next month or two. This is the photo from that second position farther back. And if you pay attention to the ground surface, this is December 12th, and then we went back on Friday, on January 5th. The ground surface had moved down. And if you look closely, I'll flip back and forth a couple times here. Everything from this side all the way to about here moves down. So we did catch one rockfall of sorts. You'll notice that this guy is now missing in January. And the other thing you'll notice if you've been watching the whole image is that Pu'u O'o, the cone here, moves up in the image. And we know Pu'u O'o is not moving up, which means that our camera is on ground that is moving down again. So we'll see what happens, and we'll consider moving the camera if this gets a little more crazy. But right now, this is kind of the state of Pu'u O'o, the slight subsidence of the ground dropping at Pu'u O'o. This is very slight. I mean, obvious enough that you can notice it, but it's small compared to what Pu'u O'o has done in the past.